I am Tom, as was said. I work at Habito, always hiring. I'm on Twitter, I'm on GitHub, and I have a website. And I spend most of all three talking about type level Haskell and Idris and various ways to abuse compilers. Which may make this talk seem like an odd choice. The fact of the matter is, I think, as most programmers are, you kind of do one thing and wish you did another. And for me, that other thing was game development and graphics and all these things that I never really knew enough maths to do convincingly. So the approach I've taken is turn up to talks and loosely talk about functional programming, but also draw some pictures, and maybe one day I'll be a game developer. So we're going to talk about spirographs. Does everyone know what a spirograph is? Nods, shaking of the head. Perfect, because, oh, do I have a slide for you? So how do they work? What you do is you take a circle, a fixed circle on a piece of paper, and you have a cog, essentially, and you pick a point on it, and you roll that cog around the outside of a circle, and all you do is just pick a point on that circle and with your pen, draw the line it follows. And you keep doing this until you can go on the internet again, because this is 1999 or something, and we can't do both at the same time. And so, risky life moment one, I do have a GIF. There's a spirograph in real life being drawn by an actual human, which is not what this talk's about. And so what's PureScript? As mentioned, I am probably half of the London PureScript community. The other's Liam, who also works with me. So what is PureScript? PureScript is a Haskell-like language that compiles to principally JavaScript. So what that means is it's purely functional, statically, strongly typed, and brilliant. And we're going to talk about all the reasons I love it. In code, all the slides were black on white, sorry. It looks a lot like this, so nothing particularly interesting. I think you actually wrote this program, I believe. The old Hello Sailor example.
Oh, Hello World.
Yes, so this is...
I still regret not making that Hello Joe.
One day, there's still time. So this program does nothing but print Hello Sailor, that's it. Interesting things to note, we're in a module called main. We have a bunch of functions that are useful, and types as well, as we'll see in a module called prelude. All the effects are tracked. You can't just do effects in a pure function. You actually have to say, this code operates inside some effectful context, and I can log to the console, so it's industry ready. And we're going to have to do quite a lot of maths, and thankfully not as much as I was afraid of. I want this talk principally to be about PureScript, but obviously we're drawing circles and things. So we're going to move quite quickly through a bunch of trigonometry, which is what you all wanted. So before we do that, let's write a type. Coordinates are useful. What's a coordinate? A coordinate is a pair of numbers, x and y. In PureScript, we have this thing called a new type. What that basically means is at runtime, it's just this record of an x and y. At compile time, it's a different type. So I can't use an x and y record as a coordinate. The compiler will complain and say, give me a coordinate. This is pretty useful because, say, there's a difference between a coordinate and a vector, for example, but principally you can represent both in the same way. But it's nice to be able to tell the compiler, tell me off if I accidentally use one as the other. And what can we do with it? And it turns out the other lovely thing about PureScript is code generation. I think people get into Haskell and PureScript in the industry because of type safety, and after about 3 months realize that that's not very interesting. The interesting bit is I don't have to write a lot of code. So in this instance, I didn't have to say how you tell if two coordinates are equivalent. PureScript will just figure that out for me and derive the instance. Semi-ring is what gives me plus and multiply. So I didn't have to say how you add coordinates together or multiply them, because it looks inside the new type, sees that it's a record, and it says I can add and multiply records if I can add and multiply the things in them, and it can because they're numbers, and so it just writes all that code for me. Ring gives me subtraction, so I get that for free. And finally, at the end, it knows how to show records, so I get showing for free. So actually, I haven't written a line of proper code yet. This is all kind of type declaration boilerplate, and already I've fully expressed a lot of the semantics of this coordinate type, which It's pretty great. But eventually you're going to have to write some code of your own because computers aren't just going to figure it all out. And the way we do that is not going to be too frightening, hopefully, for anyone, particularly not very frightening if you've done Elm or Haskell or Idris or anything like that. We have a function. It has a type signature. So here we give it a number and a coordinate. That number is the angle, and we rotate the coordinate. So we do some trigonometry here, copied it off Wikipedia. If it's wrong, it's not my fault. And this is how we write functions. We say we have a declaration equals the answer. And so we can start asking questions as we draw our spirograph. We can start saying things like, at a given time, given that the inner circle's diameter is this fraction of the size of the outer circle's diameter, where will that circle be? And okay, the way we do it is we say, well, if we assume the radius of the outer circle is 1, all the maths gets super easy. So we say, take the ratio away from the 1, and that will tell you where the radius is if we start at the top, and then we'll just rotate that coordinate around the origin, and that will tell us where the where the circle is at a given time. So again, hopefully not too scary. It is literally rotate by the angle we'll call time for reasons that will become clearer later, the initial coordinate. And we get that. Another thing that might be useful to know is which way up is it? How much has it rotated by the time it gets to this point at this time? To do this, it's a super simple formula. We just minus time over size. But so you can see all we're doing again is we're writing these. We can call them equations that say, if you give me a number, I will give you a function that takes a number and gives you a number. So again, automatic currying if that's something that's interesting. So now we have these things. It's a sensible question to ask, okay, I know where the circle is, but where's the pen, right? I picked a point, and as my circle turns, that is going to start rotating around the center of the circle that is rotating around the outer circle. And so the way I chose to express this was say, well, let's ignore the fact that the cog is rolling, if you like. Let's imagine that's a fixed point and talk about the offset of the pen from that central point. And so to do that, we need to know firstly what's the ratio between the diameter of the outer circle and the one of the inner circle. And then we need to know what's the ratio between the diameter of the inner circle and the offset from the center of this pen. And again, because 1 is our radius, the maths works out super simple. So I've used this dollar here, just ignore it. What it basically means is everything after it is in brackets, right? So I'm rotating this coordinate, which I've made up and said it's just size times offset, by the rotation you give me. And so what this does is it just says, if I'm halfway around the circle, this will have traveled so far. Obviously, if my circle is twice as big as the thing that's rolling, this will move twice as quickly, that sort of thing. And so that's cool, and now we've got this language, and most of the code was written for us, which is great. And this language tells us how can we tell where the pen is at a given time. And so the sensible question to ask then is, now I know that, can I see it, or something to that effect? And the answer is yes, luckily. And the way we do that, I've added a synonym called configuration, but ignore it. Basically, it was just a way of carrying around the size and the offset. Seconds, again, this is a new type, a round number, so I can't just give you a number. When I want seconds, I explicitly have to say this is a number of seconds, so the compiler's going to help me again. And what it spits out is a drawing. This is defined in the PureScript drawing library. It's basically just a DSL for drawing things on the canvas that makes it super simple, and I can just write things like circle. So I take this information and I say, draw a circle at the x and y coordinates with a radius of 2. Now, what's x and y? The center of the rolling circle is a thing we already know how to produce. The angle that circle has rotated by is a thing we already know how to produce. And then we just say, well, given that angle of rotation and the two ratios, I can tell you the pen position, and then I can just add that to the center of the thing that's rolling. Now note again, the plus here isn't adding numbers, it's adding coordinates, and PureScript just wrote that code for us. So we can just use plus on anything that implements the semi-ring type class, which The name's unimportant. For our purposes, that's coordinates. So this is great, more code we didn't write. And lastly, we'd quite like it to be pretty. And the way we're going to do that is we're going to pick some horribly illegible numbers. Hue, saturation, value, saturation and value or brightness I've put as 0.8. And then the hue at a given time, I've just said times 180 mod 360. What does that mean? Hue is expressed as an angle around a circle, like your color wheel. And unlike everything else in trigonometry, this is written in degrees, which is really unhelpful. So what we do is say basically 2 rotations around the circle, and you will go through the rainbow. It comes out quite pretty. And so we've written all this pure code, and it's all very nice. But principally, the complaint people have against functional programming is how do you actually do input and output? Like, when it gets to the ugly bit, what do you do? And the answer is, you write code that looks like any other language, modulo some weird syntax. So I say, get me the canvas by this ID. I've called it spirograph unoriginally. Again, this function returns a maybe because the canvas might not be there. So I have to deal with both possibilities. There's one possibility that I find the canvas, in which case, great. And there's the possibility that I don't find the canvas, in which case I can throw an error. I'm deliberately hiding the type signature here, but only because it's not very interesting. But throw error is a pure function. What it does is it uses a type called either, which has a left and a right value. It picks up a left and through its bind operation ignores everything after it. So it works like exceptions, basically. At the end, I have to deal with the fact that there may have been an exception, but I don't have to have it cluttering up my code. I can set the dimensions of the canvas. I set them both to 400. Again, that can't really fail. I mean, browsers are pretty rubbish, but in theory, according to the library I use, this can't go wrong. And I get the context. If anyone's done any JavaScript rendering before, this is pretty dull. And once you've done all that, the thing we get to, which is hopefully here, turns out looking quite pretty, I think. So all I've done is I've picked a size of the circle that's rotating and a point on that circle and just spun the circle. Looking at it, there's a bug with this render, and I will be super impressed if anyone can spot it. Leave that as an exercise to the reader. So that's fine, that's pretty and everything, but the appeal of a spirograph, at least for like 11-year-old Tom who wasn't allowed on the computer at the time, was the actual process of drawing it. So it would be nice if we could animate it. And you can, and it's super easy. The PureScript behaviors library has this thing called seconds, and it is a continuous stream of the current time in seconds as a floating point number. And it has this animate function, which says, I'm just going to call you probably 60 times per second with the current time, and you just have to do something with it. Luckily, we have a function called mark that can take the current time and draw a dot on a canvas. So that's kind of it. We can do something a little cleverer here, which is to say, once you've gone one way around the full spirograph, don't go back over it, because then you're just drawing on top of lines you already have. I did a bunch of maths. It got super complicated, and then I simplified it, and it turned out to be really, really straightforward. If you take the ratio of the inner diameter to the outer diameter, simplify it down to its simplest form, and take the numerator, that is the number of times you have to go around the circle, which is super convenient. So we just do 2 pi times that, and then 1,000 milliseconds, because, well, we've got the time in seconds. And then good old set timeout from JavaScript just says, after that amount of time, stop drawing. Stop drawing is a thing we get back from animate. So it literally gives us the canceller to say, when you call this thing, we will stop animating. And so risky life moment 3, and now we're going to see all the reasons I was afraid of this. No, everything's working. Good. So now we get this beautiful little animation as it works around, and I mean, if you can visualize the circle kind of turning as it goes, and we're just tracing a point. Now, interesting questions to ask here. Why isn't it drawing a continuous line? Why is it drawing lots of dots? As was highlighted at the beginning, my laptop is older than time. And the problem with drawing, connecting the lines is you will be able to see that this isn't a straight line. And it gets even worse when I plug it into an external screen. So this was laziness on my part. There's no reason you couldn't. And then hopefully, now I've stalled for time, that will draw the last of them, and then just stop. There you go. Isn't that pretty? Thank you. And even if I dare, you can update these numbers, and you can wait until the thing bundles in this window down here. And re-render it, and you'll get a different shape, right? So it's, I'm not making this up. This isn't a dirty trick. This is like actual running code. And it's just really pretty. I've been playing with this for days. Sorry, I'm just... oh, that is a good one. So, I don't want to continue until it's, there we go. So that's, yeah, everything works, which is great. And then you can start asking some fun questions, because we're engineers, and that's what we do. And you ask the question, well, why am I restricted to a circle with a circle in it? Can I not have a sphere with a sphere in it? And what would it look like if I trace that point? And so I started messing around with this, and I was hugely disappointed, because in my head, what you would do is you would put the circle at some point on the, you'd put the sphere at some point on the outer sphere, pick a direction, and it would just go around and draw a fancy picture. Except, after a few minutes of thought, that's not what happens. It just draws another circle at a different angle, which isn't very exciting, because now I've just got a spirograph I can't quite see. And so you can get into some fun stuff, and you say, actually, what I need to do is I need to vary the x and y coordinates at different rates, and then you will get a curve, and you'll get something interesting. And so the answer is yes, you can. And now we get into, I think, why this talk deserves the intermediate label that it got. PureScript has a load of fun features built in. One of them is this new type class, which you can have for any new type. And it means we can write this sufficiently terrifying function, which vaguely says, for some new type whose inner type contains an x of some type output, I can go from that new type to the output type. And the way I'll do that is I'll unwrap the new type and get the x. This is some PureScript syntactical magic, but you don't need it, and we'll see later you can do this without syntactic sugar. And then we've got coordinates, but the reason we write the polymorphic accessor is because I want to talk about 2D coordinates and 3D coordinates with the same language. And so the other thing I might want to do, say, is get the offset from the origin. And to do that, I want the same function that works on 2D and 3D coordinates. So what I do is I define some operations that I want for all coordinates. So one of them is transform. If I can do something to every number in a coordinate, I should be able to do it to the whole coordinate. And fold, which says if I can accumulate the numbers in a coordinate somehow, so add them together or multiply them or get the maximum, the minimum, whatever it is, I should be able to do that to anything that's a coordinate. And again, PureScript gives us some exciting features to do this. So the interesting thing about PureScript is I can take the type of a record and interrogate it and see what's in it, which, as anyone who's worked with Haskell knows, is substantially harder to do in Haskell. And anyone who's worked with Elm knows this is strictly impossible. And so the way I have to do it is I have to talk about what we call a row list. And there's a type class in PureScript called row to list, which takes the row of a record and turns it into a list. Do not worry if this is meaning nothing. But effectively, it comes down to recursion, as everything always does. There are two cases I have to address. What happens if I try to transform an empty record with anything? I just return the record. And what happens if I want to fold over an empty record? I just return my kind of initial value. Monoid isn't the interesting thing here, but mempty is like my initial, and we'll see in a sec that the kind of less than, greater than operator is sticking things together. And so the more interesting case is this beauty, which says, if I want to transform a record by some function, what I do is I walk this cons list, you can see there. So it's a cons, the record key, it's got a number value, and the rest of the thing. And basically all I'm doing, if I can step over here, is I modify the thing at this label with that function, and then I just transform the rest of the tail. So it's recursion. It's ugly, but it's honest to goodness recursion. And similarly here, I will get the thing at that label. I will call my f on it to get my accumulator, and then I will just fold the tail and stick it together. Why would you go through all this trouble? Because now I can have coordinate for any record whose types fit into that idea of G coordinate, a generic coordinate. Why would you go to that trouble? Because now I can do things like, tell me the offset from the origin for anything that is a coordinate. How do I do that? Well, I fold up the numbers inside my coordinate by squaring them and putting them in this additive accumulator. Then I get out the total and square root that. And the cool thing here is this works for any coordinate. 2D, 3D, 4D, whatever it is, this will all work. And you can continue this machinery. I did some things with when you get to 3D, you need to know where the camera is, how to do perspective, things like that. You can do all of this quite generically. To continue thanking Bodil, there's a library, PureScript size vectors, that I use for a lot of this, where you can basically say at the type level how many things are in my coordinate, and then you can do things like say the projection of an n-dimensional coordinate has n-1 dimensions. And it got very exciting and very confusing, but it was successful until PureScript never let me down. It never will. JavaScript let me down, and it always does. So here's a thing that is impossible to read in even worse. Know that what this. Oh no, this is fine. Sorry, there's deliberate spacing. Everything's okay. So there's a general rule in maths you can convince yourself of that says if I multiply a by b and then modulo b, I'll always get 0, right? Because I know there are exactly a copies of b. I've just told you. So there's exactly 0 remainder. And JavaScript's cool with this if the number is 2. And JavaScript's cool with this if the number is 3. And it's even cool with it if the number is pi. However, we're talking about ratios. And when the number is pi over 4, it picks a number which definitely isn't between 0 and 1, which is what I need to do the rotations. Show excuse.png. So you get a circle like this in 2D, and this lovely idea of a nice fluid line just falls apart. I wish I'd saved the image of the actual 3D projection, but when you see something that's so obviously wrong, you just go, well, that's not it, and just hold down Control-Z as you reach for the next glass of wine. It's very much what happened. So yeah, no, I did try, and I can share all the code that nearly got me there, but someone at work said what I should do is I should set up a web server that does the calculation properly, and then the JavaScript front end just calls it 60 times a second. Maybe not the best idea. Not an advert for the company. Definitely not. But if I had a better number type and more time to prepare this talk, yes, this is something you can absolutely do. There is nothing about this mathematically that doesn't make sense when you generalize it to n dimensions. And so it is left as an exercise to the reader. But there are plenty of other exercises if you suddenly decide you want to write the next talk for me. You can animate things in a stateful way, which is super useful because often with an animation you want to build on a frame before, or you want to store a user position if you're doing something interactive. And there's a function inside the behaviors library called fixB because it calculates the fixed point of a behavior, which is not helpful. But what it essentially does is it lets you see the value before. So it gives you a loop. And in that you can do your standard kind of fold or reduce or whatever your language calls it. That just means every frame I can look at what I have, look at, say, some user input, and decide what I want to do next. Oh, and I did this for another talk. So I do have an example on GitHub of doing this little super hexagon ripoff that does exactly this, right? So I'm actually storing where I'm pressing the keys, I should have said. So this is a stateful thing, and there's a counter in the top, and it gets faster, and eventually I lose, and then it all starts again. So you can do this. You can see that project on GitHub. Everything's there. Drawing continuous lines, as I said, the problem is this laptop is now 7 years old, I think. It's just had a birthday. And it is too old to be doing any sort of graphical rendering, especially hooked up to another screen. Interactive controls, you'll notice I did have to fumble this number to get everything to work. It's not a huge extension, but if you're looking to get into PureScript, it's a good opportunity to do something a little bit effectful and maybe not immediately intuitive. Other types of ellipses to roll, again, I appeal to anyone in the room who is better at maths. The one thing I wanted to do first before I had the 3D idea was, what if my thing isn't a circle? What if it's an ellipse? And young, naive me skips off to Wikipedia and says, what's the circumference of an ellipse? Thinking, I'll just figure it out. No, it's an infinite series, and I don't know what to do with them. So if you can figure it out, please tell me and send me a pull request, because I think that would be really cool. So a summary of things we see. I shot through that. Good. Always present animations on a better laptop than I have. That is the #1 takeaway. PureScript has this lovely DSL for canvas drawing, which I really don't explore enough in this talk, which is a shame because I only draw circles. But PureScript drawing it's a DSL that gives you functions like line and circle and point, and everything's fine, right? It's not very scary. You don't have to deal with the Canvas API. And I strongly recommend you go and check it out. PureScript behaviors is a lovely interface for animations. It's actually an interesting library. Phil Freeman wrote it. The library presents two things. One is events and one is behaviors. Events is probably the thing most people are familiar with. So what I do is I say, when this thing happens, here's how I want to respond. So when the mouse is clicked, paint the screen pink or something. Whereas behaviors are more proactive. So rather than saying, was the mouse moved, I say, where is the mouse? Or in this case, did we tick another second? I say, what's the time? And the idea is the actual rendering and the 60 frames per second nonsense is actually in the library. So I only ever talk about my current state, and everything else is kind of just wired up for me, which is super useful for animation because events are a nightmare, but if all I'm doing is actually just saying, tell me the state and I will render this thing, everything gets a little bit less terrible. Again, I have that repository. Go and check it out if you want a bigger example. And there was life before the internet. And I hope, I don't know how many people are anywhere near my age, but writing this talk was hugely nostalgic, so I hope it gave you some of that. And thank you very much. And one last thing, because it's already been remarked on twice. These slides are Markdown, and this program, shout out to Jasper, is well worth a look. It just takes a Markdown file and turns it into slides. I met him the other month. He's a cool dude.
Now, questions?
From a mathematical standpoint, a semi-ring, a ring is a semi-ring. Why do you have to derive both? Because I don't really know pure.
Good question. So if you derive ring, it says, I require that this thing also be a semi-ring. So even though the presence of ring implies semi-ring, you have to say to the compiler, I'm not just asking for subtract because I can't be bothered to work out plus. So there's a hierarchy of these things. It's similar to, if I say something has an order, I also have to say there's a notion of equivalence between them. And even though it's just an extra line of boilerplate, yeah, it requires that I acknowledge that is true.
Well, just an idea for your next talk. As you said, rolling a sphere inside a sphere is pointless, but rolling a sphere inside a torus, which is another name for donut, yeah, that might work.
So I don't know whether you were here when I said I didn't know how to do this. But I hope you're better at geometry than I am, and in which case, yeah, let's talk, because that sounds sweet.
If you were going to try this in Elm, would it be, how would it be different?
So, given that I categorically failed to do the 3D coordinate bit, probably not very. The principal difference comes when you get into that notion of polymorphism, and what I want to say is this function works for all coordinates. And to do that, I have to have a notion of a collection of types that share some capability. The word for which in Haskell-like languages is a class of types, right? And it's an infamous point of contention that Elm doesn't have type classes. What it means in practice is I just have to write offset 2D and offset 3D, and to be honest, you could hack together some awful sed script that wrote them for you, right? But it's nice to have the compiler do it. Beyond that, there's probably not that much in it. You could definitely do it. I'm sure someone has.
Any more questions? Otherwise, we can beat the queue for the bar.
I promised beer early.
Okay, let's give Tom another round of thanks.
Thank you very much.